Hi guys, we're back for another video. In this video we will address the three categories of shading surfaces that the program uses for simulating shadings. We will also cover some user script tools, and finally we'll simulate the model. Let's first assign some shading surfaces using the new shading surface group tool right here. Let's implement a shading surface at this position, and let's enter the editing mode by clicking the Enter key. Use a line tool, and let's sketch an eave for this roof. So there's our shading surface. Let's imagine a neighboring building next door. We'll create another one. Let's edit it by clicking the Enter key, and let's use a rectangle tool. Let's create this shading element representing a neighboring building. We will also imagine that at the front of our building there is a tree. Let's use the rectangle tool to shape our tree. Now let's freehand draw the tree. Now let's cut it out. Let's reposition the tree closest to the building. We already have three shading surfaces. Let's select the model. Using the tool we used before, let's add horizontal window shades through the User Scripts tool. We are asked to specify the relative projection of the shade. The relationship is proportional to the size of the window. For this situation, the value is 0.5. It means 50% of the window size. The offset represents the distance from the shading element to the window. For this situation, we will place it at the very beginning of the window, at the very top. The value will be 0. We will validate and wait. Note the difference in tonality of this shading element to the others. This difference is something purposeful in the program. It does not represent an anomaly. The program is claiming that this shading element differs from the others. So why is that? When we click on the shading element that represents the neighboring building, we will notice that, through the Inspector tool, we see a dialog box with three options. Option site, building, or space. These options each have a purpose. Suppose we are going to use the site type. Notice that the hue has changed. This neighboring building belongs to the site. Because it belongs to the site, this type represents elements that are fixed in location. They are not linked to the building. It is also applicable to the tree. When we look again at the inspector tool, it can be seen that the tree was characterized as building, but is off the site type as it should belong in the site type. Let's change the element name to make it much easier to understand when we are going to assign the constructions in the OpenStudio app. Let's also change the name of this one here. When we click on this element that represents the eave, we will notice that it is of the building type. This is true as the element belongs to our building. Suppose the building rotates. This element will also rotate with the building because it is an element belonging to the building. We will also look at this other space type. This type performs the assignment of the shading element to a particular space. It simply makes it convenient to edit all shading elements associated with the space. So the function of type space is it just associates the shading element to a space. After this information, let's export the model to OpenStudio. Let's load the app. The tool loaded. The first step is to check the integrity of the geometry. Let's make sure the placement of the shading elements is correct. The eaves, the extension of the roof, and check the horizontal breezes. Everything is in place. We only observe this anomaly in the roof color, but it will not interfere with the simulation. Let's check on the Facilities tab. We click on the Shading sub-tab. Note that we have listed the shading elements we created in the model. There are these three elements here, but they are empty boxes that we forgot to delete from a previous project. It won't influence the simulation. Let's stick to these other elements. Here we have the tree, which is named in SketchUp. The tree can receive a broadcast schedule. We can also assign a material to the tree. For this situation, we would assign wood to the tree. At this point, we have the neighboring building. This neighboring building can also receive material. For this situation, we will imagine it to be concrete. We also have the eaves, the shading element that is part of the roof. To this element, we can also assign a construction of concrete, metal, or something that can serve as a shading element. To do this, we must add constructions. Let's do it. We click on the Constructions tab, Constructions sub-tab. Note here that the constructions have already been created. Let's delete. Let's do it again. The first construction will be for the neighboring building. Remember that it is a site type. Let's name it Site Building. As we think of a concrete building, let's drag a material from the library that looks like concrete. For the tree, it's also a site type. For this element, let's generalize and just make it wood. We'll drag it from the library and drop it in. For the eave, the part of the element that makes up the roof. For this part, we can name the type building. It will be made of concrete, for example. Now let's create one more element for the space type. These elements are the exterior window shades, which are at the top of the windows. We can attribute to these elements some material similar to metal or wood. For this situation, we will assign them to be metal. After creating these constructions, it's time to characterize the shading elements. It is noteworthy that these materials that we are using randomly to only try to approximate their real composition. However, you can create new materials and edit these properties and add them to your library in case you need something more specific. Now let's go back to the Facilities tab. Go to My Model and look for the buildings. Constructions. Let's do the tree first. We will click on the construction made for the tree and drag it and drop it into the construction name to characterize the tree. Let's now do it for the neighboring building. There are 6 sides to the building, so we will drag and drop this into the 6 sides. And then we will do building this one. However, when we go back to Construction Set tab, note here the option for other constructions to assign the type space. Let's assign the construction type space. There is a possibility of assigning the other types here too. However, in our model, we have 2 similar types of shading elements, but with different construction material. We will not make this assignment here due to material standardization in this particular dialog. Due to this condition, we carried out the characterization of the materials at the Facility tabs level. All materials have been assigned to the shading elements. Let's look at the transmittance schedule now. There is a possibility of drawing up a transmittance schedule. This schedule fits in cases where the element may vary depending on the season, environmental variables, or some other factors. For our case, we have the tree. The tree does not have its full foliage every day of the year. There is a period that the tree has a certain transmittance value, and another period that has a different transmittance value. This variation can be described to the program so that it implements these conditions in the simulation. Let's now work out this transmittance schedule for the tree. We click on the Schedules tab, Schedules subtab, and let's create a fraction schedule. Let's name it Tree. To facilitate this assignment, by default we will assign a 90% transmittance. In other words, if none of the conditions that we will implement are not met, the program will use this default value for the simulation. The program will understand that there are 90% passage of sunlight through the tree. Now let's implement the tree scheduling, a period that has leaves and a period that has no leaves. There's a period that starts in the spring where we have the date March 20th. Let's assign this date. So on this date, let's consider the tree has a transmittance of 10%. That is, it has almost the full volume of leaves. And during this period, the leaves fall until there are no more leaves until the spring period. The spring period begins in September 23rd. Outside of this period, it doesn't have leaves. Let's assign these conditions to the summer design conditions. In the summer, there is a transmittance of 1. That is, there is no tree. Or, in the winter, the tree was cut down. These are two situations that are design days. It's the worst possible case. There is this priority. There is the information that during this period, which corresponds to March, which corresponds to the period of spring, summer, and early autumn, that the tree does have leaves, and later it loses foliage during the autumn and winter. The schedule has now been drawn up, and there is a pattern for the whole year and during our design days. To start the simulation, we will need to configure the solar distribution in the simulation control. We need to consider solar distribution with reflection effects. We have the option to only consider exterior only, interior only, or both. Let's assume it's both. After this configuration, we check the schedule and go to the Facilities tab to assign the schedule we created to the tree. Let's go to Rule Set Schedules. Right here, the schedule. Let's go back to check. There's even another schedule, but it is not edited. The valid schedule is this one. We'll delete this one. So the valid schedule is tree 1. Finally, we assign the transmittance schedule to the tree and buildings. Now let's simulate the model. We were successful in the simulation. Let's show the results through the HTML file. Through the properties, we can observe the visible solar reflectance values of the elements that we implemented in the model. Here the exterior window shades are represented. They received a metal construction. All this information corresponds only to the breezes. Here we have the local elements. Here we have all the values related to the created elements. These transmittant values directly affect the energy performance of the building. They also affect the program's energy balance calculation. So this was another video showing the details of the shading elements. Subscribe to the channel, enjoy the videos, activate the notification bell to be informed when new videos are available on the channel. Thank you all. Please like and subscribe.